Good afternoon, everyone. My name is Cody Bunton. I'm a PhD student at the University of Maryland in the Human-Computer Interaction Lab. And this talk will be about event detection with applications in social media. So event detection is a very popular area of research. It's been around for 15, 20 years and has been applied to many different problems. The things that you'd expect, maybe like identifying particularly important plays during sporting events, identifying breaking news from text or from social media, identifying earthquakes or natural disasters from sensor data or from social media or from news text online. But it's also been used in many different areas like identifying hardware issues or changes in hardware allocation in cloud-based systems, uh, financial markets. So this image here, the bottom right, is financial data for stock prices for British Petroleum, or BP, from 2009 to 2016. And you see that big dip on the left. That actually corresponds to the oil spill from BP's Deepwater Horizons oil rig that caused significant issues in the Gulf of Mexico and led to BP's losing uh, hundreds of millions of dollars. It's also been used in areas like cybersecurity. You can see here this graph is about bandwidth utilization for a particular server. The green lines show bandwidth. This server actually experienced a distributed denial of service attack. You can see this large spike in bandwidth usage on that Tuesday with these high green spikes. And what's interesting about this is event detection could be used for this, but it also goes by other names depending on what you're using it for. So this denial of service attack detection could be event detection, could be called anomaly detection, because clearly the amount of bandwidth being used in this attack is much different than the typical amount of bandwidth usage this server has been using. So this would be an anomaly. Same thing with detecting earthquakes or detecting crises in financial data or hardware failures in cloud data. So anomaly detection is a closely related topic, but we're going to focus on event detection here. And there are many different approaches to event detection, from offline event detection to online event detection. You may have heard Jay mention the difference between offline and online systems. So for our purposes, offline generally refers to retrospective systems, things that look into the past based on all the data you have, versus streaming event detection or online event detection. We want to identify new events basically as data comes in. For retrospective event detection, oftentimes you have some large data set that covers your entire timeline, and you want to identify particular areas in that data where an event may have occurred. In contrast, streaming detection is generally done in real time, though this isn't necessarily required. But as I said, you have event data, or you have data coming into your system, and you want to make predictions or do detection of events on this new data as it comes in. Offline event detection systems are generally solved with optimization. So we have some model that says what is not an event, or some particular feature of the data where we don't have an event versus times when we do have an event, and what is the most likely chain of events or most likely state that the data is in at some particular time, versus online event detection where we use scoring and ranking and compare that to some threshold. We'll see some examples of that in a minute, but for now, for completeness, so here's an example from Jonathan Kleinberg, one of the big first guys in doing event detection and doing burst detection in data sets to identify events. In 2002, he looked at his own email data set to look at bursts in email traffic and correspond or correlate these bursts with events. So in this graph, we see bursts in his email traffic, where the lines go up rapidly, or the number of messages he receives increases rapidly. He used hidden Markov models and optimization to try and identify what were the events going on at those times. And then he was able to actually identify hierarchies of events. So the first big bump or the first big burst in his email messages may have been about one of his students going in for his PhD defense. You'd have sub-events like scheduling the defense, or lots of email going back and forth, or a burst of email going back and forth about changes to a dissertation, or setting up a schedule for when the defense will be. The next higher level of events might be a particular conference coming up, where you'd have sub-events for reviews and lots of email back and forth for scheduling reviews, then quiet for a while, and then another burst of email traffic as the reviews actually go out. And you could apply this kind of optimization problem to many different domains and areas, and it has been. So online event detection, which is a little bit more simple to describe in our case, one particular example is looking at frequency of goal-related keywords during the 2014 World Cup on Twitter, and then identifying goals or when goals occurred in particular matches based on big bursts in frequency of tweets mentioning goal in several different languages. So we're going to be focusing on online event detection. That's been more in vogue recently, and this is what my work is on. Generally, these online systems work by finding peaks in some scoring function. So you have some data that's coming into the system, and you score that data as it comes in, and then you find some peak and compare it to a threshold. So if this peak is above some threshold, then you claim that this is an event. And then as that, hopefully as your scoring, if your scoring function is a good one, then the event will decrease, and then you'll go back to the original non-event data that you might expect. There are a couple of approaches to this. The first one that you might see or you might encounter is your typical time series approach. Basically, this works by finding bursts in raw frequency. So if you are looking at Twitter, you may look at the number of tweets per minute without any sort of filtering. Just look at how many tweets occur per minute, and then you would expect if there's a large burst in the number of tweets being published to Twitter, then this would be indicative of some sort of event or something that would be interesting to dive into. So you look at the current frequency and compare that to the average frequency over some sliding window, say the past 5 minutes or the past 10 minutes. And if this difference is above some threshold, then you claim that an event has occurred. So this is often used for financial markets or for sensor data. So I was on a project a couple of years ago that looked at sensors placed on a bridge in a lab in the Netherlands, and they tried to predict when the bridge would collapse based on this sensor data, where the bridge collapse would be the event of interest. For financial markets, there are many different tools for this that can go from relatively simple all the way up to pretty complicated. So in the top right, you have a moving average mechanism that just averages your data over the past couple of days, or over the past couple of minutes, or a couple of hours, depending on what your data set might look like, all the way down to the bottom right, where you have much more complex tools like autoregressive moving averages. And these are used for basically doing prediction, and you can identify events or anomalous points based on differences between what you predicted what would happen and what actually happened. So the things that you see, or the approaches that you see taken for social media, however, generally have some domain specificity, or they're domain specific, where you track the frequency of some pre-specified set of seed tokens, rather than tracking frequency of all tweets or all messages. Some examples would include looking at frequency of tweets that include words like run or home run for events in the World Series, or score, or touchdown, or field goal for events in the Super Bowl, or goal, foul, red, yellow, penalty card, these kinds of things for the World Cup. And then you apply the same sort of thing where you have some current frequency for your tweets with your seed tokens, and you compare that to the average frequency and some threshold. So as I mentioned, the general approach is for these domain-specific, simple online event detection systems is to use some set of human-generated keywords. There's been some success with this. So we already talked about identifying goals during the World Cup from Twitter just by looking at tweets mentioning goal. Also, in 2010, there was a group out of Japan, Sakaki and colleagues, that actually showed you could identify earthquakes very rapidly using just tweets that mention earthquakes, or the word earthquake or shaking. And the interesting thing here is that they could actually use this system to alert users about earthquakes faster than your typical geological approaches or your typical geological Richter scale approaches, because tweets propagate faster through the internet than earthquakes propagate through the Earth's crust. So if a whole bunch of people in one city start tweeting about an earthquake, then you can identify that and send alerts to people in one city over faster than the earthquake will actually hit. So that was a really interesting and pretty powerful result that they got about 5 years ago. So as I've mentioned, the typical approach, you want to look at earthquakes, you identify some set of keywords that you would expect earthquake or shaking. You can apply some query expansion mechanism here to expand your set of keywords, and then you look for bursts in your data. So for us, we'd look for bursts in Twitter. You could also look for bursts in news data or bursts in Google query searches, or Google queries or search engine queries, these kinds of things, and apply the same sort of techniques. So for such a simple approach, there are some weaknesses you have to be aware of. First off, it doesn't work too well for identifying unexpected or unanticipated events. So for the World Cup example that we just mentioned, Luis Suarez was a player for the Uruguayan team during the World Cup, and he was accused of biting an opposing player in the middle of the World Cup game. Now, this was a very interesting moment. This would be an event that you'd want to detect, but who would have expected to include tokens like bite, bit, or biting in their list of seed keywords? And there was no penalty thrown for this, so it'd be pretty hard to predict or identify just with a set of keywords that you had anticipated beforehand. So this idea of identifying unanticipated events is a particular problem. Also, you have to keep in mind different languages. So particularly on the internet and social media, where English isn't the only language used, there are a couple approaches you could take. You could expand your set of keywords into other languages using machine translation or just multilingual dictionaries, or you are forced to just discard other languages, since the only languages that you're going to be able to capture are languages that are represented in your set of seed keywords. A third problem is about what's called text normalization, especially in areas like social media and Twitter. There's a huge phenomena of abbreviating keywords or making words very long, or purposely misspelling keywords to try and express excitement. So goal with one O versus goal with four O's. Somebody's very happy that a goal was scored. But do you track these as the same token? And if so, how do you do that? So there are methods for this. Like I said, it's called text normalization, that range from very simple, like collapsing goal with four O's down to goal with one O just through regular expressions, all the way to more advanced language model-based approaches. And then finally, you don't get much context when you use these simple keyword frequency-based approaches. You don't really know where, like for an earthquake, maybe you can identify that an earthquake occurred, but you don't know where the earthquake occurred. Same thing for goals. You can identify that a goal occurred, but you don't necessarily know who scored the goal or what the resulting score was after the goal. So this is a problem because you'll need additional analysis mechanisms in order to identify this information. So there are more advanced event detection methods for social media. Most of them try to address this problem of needing to know what event you're looking for beforehand. So one approach that's not listed here, or that I forgot to list in this slide, was you can build up large, robust dictionaries of keywords related to the kinds of events of interest. So Jacob Rotstadius, he has a system called Crisis Tracker that relies on a large vocabulary of security-related keywords, and he uses this mechanism or this vocabulary to identify security-related events like terrorist attacks, natural disasters and crises, and social media. And this has worked well, and you can use these large vocabularies and have them translated into multiple languages to address this multilingual problem. And there are other potential solutions. So one is to look at social media messages and cluster similar messages. So similar can be based on time or similar based on content. Generally, it's done based on content. And then rather than scoring individual tweets or individual tokens, you score these clusters. And then you can look at the tweets in these clusters to try and identify the additional context. And since you're not looking at specific keywords, there are going to be far fewer clusters than there are keywords. You don't have to identify these keywords beforehand. Another approach is to use Hadoop or Spark or other big data tools to process lots of data at scale, and you basically score each token over some window. And then you can look at particular tokens that are bursty around some time period that might be indicative of an event. And then the more tokens that exhibit these bursts, the more information you get about what actually happened, some more context you get. And there's no reliance on pre-specified keywords here. And that's how my system works. And then another very popular approach is to build probabilistic models of what is normal data versus what is event data, and compare and contrast these two models. This is similar to how anomaly detection works, where you know that there's some normal data. You assume that the general case on social media is nothing of note is happening, and you can identify some events and describe what this event data looks like probabilistically, and show how this probabilistic data deviates from the normal case. And there are several different approaches where people have done that. So that's a high level of event detection in social media. I can give you a brief demo from a IPython or Jupyter Notebook that I put together last year for a session on looking at unrest in Ferguson, Missouri on social media. So here's the link to this notebook, and I'll walk you through a little bit of the beginning of it and show you some simple event detection that we did. So we have this Jupyter Notebook. You can look at the link that that's in the slides. The first bit is just reading in tweets. So we have some stored JSON data that has a bunch of tweets in it during the Ferguson unrest. And this block of code just takes all those tweets, reads them out of the data files, and then puts them into a map that basically maps dates to tweets. So we can do this to figure out how many tweets there were per hour or how many tweets there were per minute, and then do some simple frequency analysis. So the first thing we'll do is look at tweet frequency. So this is done per hour. You can see the blue line is frequency or number of posts per hour. You can see from the evening of the 13th to the evening of the 14th in August of 2014, there was a significant increase in tweets. These are tweets that include the word Ferguson. So there were a lot of people talking about Ferguson on social media during this time. And what's interesting is we see two separate peaks here, one at 2:30 in the morning on the 14th, and another one at about 7 in the morning on the 14th. This is actually, I think these times are in UTC, so you subtract 5 hours from everything. So this is in basically the afternoon of the 13th, and then the late evening of the 13th. And then you could pull out tweets during this time to try and figure out what exactly was going on here. Then we look at some other things like the top Twitter users. You can check out the code yourself to see how this is done. But the next thing that I want to show you from this is the simple event detection with keyword frequency. So we already saw this graph of the blue line. Now we can look at frequency of particular keywords and tweets in these blocks of hours and see if we can identify something interesting. So feel free to take this code and run it on your own computer. If you need data, ask Jay, and I can see if I can get you access to some of this data. And you can run it yourself, or you can pull your own data down from social media or from Twitter and do it yourself. But for this experiment, we looked at Obama and tear gas in Iraq. So Iraq was kind of a surprising thing that people started talking about. Obama gave a speech about the unrest in Ferguson, and then when the Ferguson Police Department started using tear gas on protesters, all of these events, or at least Obama's speech and the use of tear gas on protesters, are clear events that we can identify in social media. So the red line here is tear gas, and the green line is references to Obama. We see that references to tear gas were basically negligible for most of the time from the 13th to 2 a.m. on the 14th UTC time, or I guess 1:30, and then we see a large jump and references to tear gas stay up for a while and then slowly drop back down for over the next few hours. So you might expect, going back and looking, that perhaps tear gas was first used on protesters here. And then references to Obama peaked pretty significantly at 1700 UTC on the 14th, or I think 2 o'clock in the afternoon on the 14th, which is when Obama gave his speech. So you can identify that event from the data here as well. And there are many other little mechanisms in this notebook that you can play around with and kind of explore data analytics and social media for yourself. So, all right, thank you very much for your attention, and good luck.